Good morning, everyone. My name is George Hendrickson, and this here is a recap of a network security research project that I did on some Ring devices, sponsored by Hacker Initiative. Thank them for their generous sponsorship and their continued sponsorship of so many young researchers and hackers in and out of academia. The purpose of this project and presentation here is to serve accompany some labs we created for also available on our page for students and non-university related hackers wanting to get into research to have a kind of roadmap of an example of where to start with IoT research, how to create results, and what kind of resources you might actually need. It can be a daunting prospect, so seeing what other undergraduates work and hearing directly from them what kinds of things can make even simple research successful could be helpful. So that's what we're all about here. The methods we used for our project was, well, we'll go into those in a second. Here's our equipment. The devices here is a Ring 8-piece home security system. This system is very simple. It's got a hub that's both Wi-Fi capable and can communicate through short-range radio. A keypad, a signal extender for that short-range radio communications, and then motion sensor and 4 contact sensors, which send a signal when they're parted. The two halves are separated from each other, so you can put them on doors and such, and it'll let the hub know when it's opened. Our focus was on the network security of these devices, and so after getting the Ring hub, then I was able to find on the Ring's website that it uses Z-Wave, which is a proprietary short-range radio wave in order to communicate between the hub and the peripherals. Their Z-Wave is supposedly proprietary for extra security, but in reality, it is easily you can easily read the data in it with a software-defined radio program and a cheap antenna from Amazon. The exact process in setting this up is partially explained in the article I've linked here. It's a blog, so total credit to its creator and everyone who worked on that. But I found it helpful in accessing Z-Wave devices. I'll have more information on capturing Z-Wave and Wi-Fi on the next couple of pages. And like I mentioned, the other network data we looked at is from Wi-Fi, which only comes from the hub. That's the only Wi-Fi capable part of the system, and it includes some callbacks to Ring home and where it gets updates from, and so on. And the motivation behind both of these was one, just look for any data sending across unencrypted, anything easy to access, grab some low-hanging fruit, and also look for anything which might hint at the possibility of a more dangerous exploit. And finally, with the Wi-Fi in particular, see if it's exfiltrating data back to Ring that a user might not want leaving their home. Here's the exact instructions for collecting the Z-Wave data. I had to make a number of modifications to the blog article I posted, and all the instructions and changes I made are listed here, along with the version of Ubuntu I used. It was a VirtualBox virtual machine, so that works for me. Required packages are below. The article specifies Python 3. I ran Python specifies Python 2.7. I ran Python 3 with no problems. Perhaps that's why you got to install a bunch of these additional packages. For Qt, one bug you might have with that is, let's see. Sometimes if, depending on the using virtual machine versus having it installed natively, I would get a problem where the newest version of Qt wouldn't work. Switching one version back and installing that may have fixed it up. So, but you shouldn't have to go any older than that. And lastly, I had to edit the command line to run it a bit. There's a hyphen in front of the vertical slash. If you open the main page for the software-defined radio, then you can see why that is. And it's one of the arguments you can pass, or you can just add it, watch it work. But anyway, these are the instructions here. You can go back to the slide as necessary when setting up this process if you want to capture the Z-Wave yourself. And for once that all got working, here's the results you're going to see. Data's was the part I found interesting because some possible weaknesses I'll explain later. It's down here at the bottom. You can see there's a hex value sent. The image you're seeing here came from one of the peripherals, a contact sensor, when it was triggered by separating it and putting it back together again. And so it dispatched a short signal to the hub, letting the hub know that the sensor's triggered. Anytime that there's a state change in one of the peripherals, then a signal goes out to all the devices over the short range radio Z-wave. This varies, the length and complexity of the signal varies. It's always a hex value. It's a long value for turning on and off the device's Wi-Fi connection. Short values for peripherals triggering like this. To delve a bit beyond what we did and just bring up some interesting hypotheses of things that you could possibly extrapolate from this data. Maybe if you're thinking about taking this work further yourself, then you can note that the data, the value sent in the data section varies between instances of triggering the peripherals, even if all their factors are the same, which, as I noted here, my working hypothesis is they're algorithmically generated to produce a certain set number of values via some kind of impossible encryption. And which, as I'll explain in a second, doesn't necessarily matter when it comes to exploiting it, but it's an interesting thing to think about. For collecting the regular Wi-Fi data, if you plan to work with that, look for something suspicious there, then go for it. Instructions are here. Use Kali Linux since you have to run a bit of a different tool. Wireshark Windows doesn't pick up any of Ring's communications back to the main hub, back to the home servers. So just run some separate tools. You can get a cheap network card off of Amazon. I used Alpha brand. It's compatible with Linux, but I had success with a couple others as well, including some really cheaper ones. So don't feel tied to this. You can follow the instructions here if you want. If you're familiar with Linux network tool command lines, then this will make a lot of sense or look pretty familiar. If not, you can just run all these in a row and it'll work out the same. This will let you see the Wi-Fi communications the hub is dispatching. To test if it's working properly, then just disconnect the hub from Wi-Fi and connect it back on, and you'll see the communications come across that tries to reconnect to the server. So looking at just looking at the data there, then the kind of conclusions you could draw from those collections is that there's some potential for information gathering by bad actors. Just to say, in the simplest example, you're driving by the house with somebody with a Ring home security system, you camp outside of their laptop, and you can see the data Ring is sending back home to its servers, including possible information about the home network of the user, as well as information on when they're entering and leaving their house, when Ring is updating and its peripherals might be vulnerable or delayed in triggering. If you're able to capture the radio signals, then you can know when one of them triggers or not, and you can when they're activated or deactivated, and you could know when they're, for example, entering or leaving their home, when they're home or not, when the motion sensor isn't seeing anything, and so on. Or the kind of use case for this, for example, is if you set the this capture process up on a Raspberry Pi, for example, let it run near the house with an antenna, then from even far away, you could monitor their behavior, collect information on their patterns of work, when they're home, when they're not, and possibly rob their house or something. It's just an interesting thing to think about of the ways that this could be exploited. The again, on the possibility of building on this work is that the Ring confirmation process, the short hex signal it uses, sends to each other when it's confirming devices, as well as the signals it uses to arm or disarm its devices, is pretty short. I mean, you saw that the device trigger notification was only 4 bytes. And that, if you're able to get a device into the Ring's circle of trust, which their pre-existing work exists suggesting that could happen, then you could, for example, broadcast those signals. And by just brute force generating 4-byte hex codes similar to the ones that Ring uses, then you could beat its algorithm, the possible algorithmic generation, and get a ping and make it disarm one of its own devices, for example. And so that could be an interesting thing to look into if you have an eye towards continuing this work or building on it. And your most valuable resource when if any students working on this decide to take this work further, which I hope and encourage you do, and almost certainly will myself, is look around a lot. There's a lot of pre-existing work on Ring, almost all of which is still perfectly applicable. The Ring's devices have not received any significant security updates that make them very resistant to even the most basic attacks. They're extremely easy to compromise with very, very simple procedures. Even a 5 laptop denial of service attack on a relatively slow network can knock them out for 10 or 15 minutes. So, I mean, don't think that anything is too simple to try on these devices, and definitely look at really about older methods. There's work from as far back as 2013, which is still perfectly applicable and functional on Ring devices. So just be aware that they are not often updated and their security is glaring. And my note here that they have significant potential for further inquiry is partially because of that. Since they're not frequently updated, they have a lot of fairly low-hanging fruit kind of holes that someone getting into security research could look at and exploit. There's just a lot of fruit there to grasp for. And for the students who are taking our lab this fall or who are following some of the instructions we have on our YouTube channel to build on this, possibly build on this research, then there's a lot there you can do. And I encourage you to work on this. It was intimidating for me as well, starting out on research on devices like this, but the more you get into it, the more you research and look up other people have done, the more you see it's perfectly attainable within the skill set you have. It is undergraduate capable, and I hope that by demonstrating the kinds of possibly dangerous exploits you can find from just a simple analysis, like in this video, then you can understand that there's a lot of options available for you if you're getting into research, and not all of it has to be pretty complex. So I wish you good luck in working on research yourself. If you're interested in working further on these Ring devices and exploiting more of the things you see here or building on this research, then we'll have a number of additional resources on our YouTube channel, which you can use to guide you through tools or show in greater detail techniques we've used, and we hope you do. So thank you and good luck with your work.